Welcome to the session. Students will analyze the parallel AC circuit using phasor algebra. There are four principal methods of solving the parallel AC circuit, namely phasor diagram, by phasor algebra, equivalent impedance method, and admittance method. Just we have to do any two, that is, we will take up the by phasor algebra that we have studied in the last class, and also how to get the solution using the equivalent impedance method. In analysis of parallel AC circuit, that is, we know the basic principle of characteristics of a parallel circuit is that the voltage across the parallel branches is the same. For example, if there are two impedances having Z1 and Z2 are connected in parallel across a supply of voltage V. This is our Z2. Then it is V with a frequency F. You can see here the voltage across the Z1 and Z2 is the V. That is the characteristics of a parallel circuit. Voltage across the parallel branches is the same. That is, the total current delivered by the source is I. Here it is I. And the current in the parallel branches are I1 and I2. For analysis of the parallel AC circuit, here V is the common to, that is same for Z1 and Z2. Therefore, V is taken as a reference. Therefore, what you have to do while solving the parallel circuit, take voltage as a reference. Voltage as a reference, and it is represented by a magnitude V and angle of 0 degree volts. Because it is taken as a reference, this is all along the reference. The second step, because V and angle of 0, because the voltage across the branches, of course it is a parallel branches, is the same. Okay, that is the first thing. What you have to do is the voltage across Z1 and Z2 is same, therefore V is taken as a reference. Then it is written as V an angle of 0 degree. That is in the polar form. The second step here, we know that the impedance of the first branch, that is impedance of first branch, it may be Z1 is equal to, it is either it is R1 plus JX1 if it is inductive reactance, or it may be R1 minus JX1 in the case of capacitance. It is in the case of inductance. It is in the rectangle form. The impedance also can be expressed either Z1 an angle of phi 1 in the case of inductance, or it may be represented as Z1 an angle of minus phi 1 in the case of capacitance. Just it is a mere representation. It is or. It may be in any one of the form. Either it may be R1 plus JX1 if it is an inductive reactance, or it may be expressed as R1 minus JX1 in the case of capacitance, or the same thing can be expressed in terms of its polar form as Z1 an angle of phi 1 if there is an inductive reactance, Z1 an angle of minus phi 1 if it is capacitance. It is either any one of the form we are getting Z1. Similarly, we have got the impedance of the second branch. Impedance of second branch, that is what we are representing is Z2. Z2 maybe it is R2 plus JX2 if it is inductive reactance, or it is R2 minus JX2 if it is in the case of capacitance. In its polar form, or it may be expressed as Z2 an angle of minus phi 2. In this case, it is Z2 an angle of plus phi 2 in the case of inductive reactance. Okay, means one should have the voltage and impedance Z1 and impedance Z2. Once if you know the impedance of the circuits and the voltage applied, then you have to do the calculations. That is, once again you have to apply the basic formula of V is equal to Iz, or I is equal to V by Z formula. Take one at a time. Consider branch 1. Consider branch 1. You have to apply V is equal to Iz formula. Here, the first branch impedance is Z1, the current is I1, and applied voltage for the branch 1 is V. For branch 1, applied voltage is V an angle of 0 degree. We have got the impedance of Z1, either it is a plus phi 1 or minus phi 1 depending upon inductive or capacitive reactance. Okay, then the I is the resulting current. That is, I1 is a resulting current in the branch 1. Then how we are applying, how we are finding out the I? That is, the equation for the branch 1 is, that is, V is equal to, it is I1 Z1, or I want the value of I1 you are getting as it is V by Z1. Okay, whatever the in the form that you can substitute here, that is V is V an angle of 0 degree, then Z1, in this case I am taken Z1 an angle of the phi 1. Then the results what we are getting is in the form of I1 an angle of minus phi 1 amperes. This is how you have to calculate the current for the branch 1. Then similarly for branch 2, what is our equation for the branch 2? Voltage across the branch 2 is once again V, current is I2, impedance is Z2. Therefore, that is V is equal to, it is I2 Z2. Therefore, I2 is equal to V divided by Z2. Once again, we can substitute the value That is, we know that V an angle of 0 and Z2 is represented as Z2 an angle of phi 2 we can call. Therefore, it is V an angle of 0 degree divided by Z2 an angle of phi 2. Then what I am getting here is V by Z2, that is if you are making the calculation using the calculator, what I am getting is the current in the branch 2, that is I2 an angle of minus phi 2 so many amperes. Now we are getting the value of I2 and I1. Then what is the total current I here? What is the total current I? The I is the vector sum of I1 and I2. I is equal to I1 plus I2. Just you have to substitute the value of I1 and I2, and using the calculator you can do that. That is, it is I1 an angle of phi 1 plus I2 an angle of minus phi 2, or it may be a plus phi 2 also. Here also plus phi 1. It is depending upon the reactance value. Therefore, if you are adding using calculator, you are getting a resultant total current I an angle of either minus phi or plus phi. Okay, this is how you have to find out the total current in the parallel circuit. Then, how to find out the power factor? Then what do you mean by this current I? And the voltage what we are representing is V is represented as V an angle of 0 degree. Then, if you are drawing a vector diagram, taking this as a reference, because you are taking this as a reference, therefore I am drawing a reference here. The voltage is all along the reference. It is a V. Then what is I? I is an angle of phi, means it has got a magnitude of I and it is plus phi. Plus phi means with respect to reference it is moving in the counterclockwise direction. That is the magnitude of the current I. This is phi, means here what I am getting is current is leading the voltage. It may be you are getting a result minus phi also. In that case you have to draw the vector in the other direction, that is the clockwise direction. If you are getting a resultant phase angle between voltage and current, if you are getting minus phi, we are drawing here. Means ultimately in this case the phi is leading in the nature. Then how to find out cos phi? That is a power factor. Power factor is cos of phi. Then the power consumed in the whole circuit. The power consumed in the whole circuit, P is given by the same formula, that is Vi cos phi. We have got V, we have got I, we have got cos phi. Here, while substituting in the power equation, you have to take only the magnitude, that is the value of V, value of I, and cos phi is already calculated here, that you have to substitute out. Then what we are getting is the total power consumed in the circuit, or the total power consumed is also P is equal to, it is only consumed in the resistance, therefore it may be I1 square R1 plus I2 square R2 so many watts. This is also yielding the same result as this. This is how you have to calculate the current, power factor and power in the parallel circuit. We will solve some numericals on this, then we will come to know. This is how you have to do. Okay. Start with the problem number 1. Here I will read out. A capacitor of 50 microfarad is connected in parallel with a coil that has a resistance of 20 ohm and inductance of 0.05 Henry. If this parallel combination is connected across 200 volt 50 hertz supply, calculate the line current, means the total current, power factor, power consumed. Based on the statement of the problem, first what you have to do is you have to draw the circuit for that. That is, a capacitor of 50 microfarad is connected. That is, in one of the branch, only one capacitor is there. There is no resistance in that. Therefore, you can draw here a capacitor of 50 microfarad in parallel with a coil that has resistance and inductance of 0.05 Henry. In other branch, we have got a coil having a resistance of 20 ohm and inductance of 0.05 Henry. If this parallel combination is connected across 200 volts, that is, this parallel combination is connected across 200 volts 50 hertz, 200 volts 50 hertz supply. Then he asks you to calculate the current, total current, power factor and the power consumed in a circuit. Then what your next step? The total current, you have to mark the currents. That is, the total current is I here. The current in the capacitor branches I will call as I1 and the current in the coil branch I will call as I2. Our object is to first, we know that is a total current I is, it is a vector sum of I1 plus I2. Therefore, our first object is to find out I1 and I2. Then how to find out I1 and I2? You consider one branch at a time and apply V is equal to IZ. Next, you have to apply for the second branch. In this case, it is, once again you have to apply V is equal to IZ form. Okay. Just you have to find out first the reactances of the different branches. That is, in the first branch you have got only the capacitance. Therefore, you have to calculate what is the value of Xc. What is the value of Xc? Xc is equal to 1 by 2 pi f into C. You have to substitute 2 pi, f is 50 is given, C is 50 microfarad. You can substitute that. Then what you are getting here is 63.7 ohm. You are getting 63.7 ohm. Then you have to find out inductive reactance similarly. XL. XL is equal to 2 pi f into L. 2 pi f is once again 50, L is 0.05 Henry. If you are substituting and if you are calculating, you are getting 15.7 ohm is the inductive reactance. Then you can write the impedance of the first branch, impedance of the second branch. What is the general formula for Z1? Z1 you have written as R1 plus or minus say X1 I will call here, and Z2 is equal to R2 plus or minus say X2. I am using here plus or minus. Plus is meant for inductive reactance. If it is negative, it is capacitive reactance. Similarly here, if you are taking plus, it is inductive reactance. If you are taking minus, it is capacitive reactance. For this particular problem, we can see what is R1, what is the resistance in the first branch? It is not there. Therefore, you can put that as a 0. Then what is the type of reactance here? it is capacitive reactance, therefore you have to take it as a negative. Therefore minus, I'll call, what is a XC or X1? This is your X1, this is your X2. That is 0 minus 63.7. 63.7, I put it as I. Usually I put it as J, but in the calculator you are using, you have to make use of I there. 63.7, that is Z1. What is the Z2? What is the value of R2? R2 is 20 ohm. Therefore it is 20. What is the type of reactance? Inductive reactance. Therefore what you have to take? You have to take it as a positive. Then what is the value of X2 here? It is 15.7 I. Okay. This is how we have to represent Z1 and Z2. The next step is, what I told you is that you have to take the voltage as a reference. Then how we are writing V? V is written as, what is the V value is given? 200 volts. Then it is a reference, therefore I am doing 200 and angle of 0 degree, so many volts. This is how you have to represent V. Then what is your next step? The next step is to find out I1 and I2. What is the value of I1? I1 is equal to V by Z1, because the voltage across the branches are the same, therefore V divided by impedance of this circuit gives the current in that circuit. Similarly, voltage across the second branch and its respective impedance gives the current in the second branch, that is I2. That is what you have to do. 200 an angle of 0 degree you can put. Z1 you can put in the same form, whatever you have got. 0 minus 63.7 I. You make use of the calculator and find out the answer in the polar form. Find out the answer in the polar form. What you are getting here is 3.14 an angle of 90 degree amperes. Similarly, you find out what is I2. I2 is once again V divided by Z2. What is V once again? It is 200 an angle of 0 degree divided by the impedance, reactance in the second circuit is, impedance of the second circuit is 20 plus 15.7 I. You have to make use of calculator. You can make use of the brackets and make use of the calculator. Calculate the value of I2. That you have to, once again it should be in the polar form. The I2 what you are getting here is 7.86 an angle of minus 38.13 degrees, so many amperes. The next step is you have to find out what is total current. That is total current I. Total current I is the factor sum of I1 plus I2. The same thing you can do it here. I1 is 3.14 an angle of 90 plus I2 is 7.86 an angle of 38.13. Once again you have to make use of the calculator and express the result in polar form. That is the total current. What you are getting here is 6.41 an angle of minus 15.47 degrees, so many amperes. You are getting the current I, the total current I. You ask the line current. The line current is 6.4 amperes with an angle of minus 15.47 degree with respect to reference. Then how to draw the vector diagram for this? This is a current. What is our voltage? Voltage is V is equal to 200 and angle of 0 degree. Okay, for this I want to draw the vector diagram. That is, first you have to draw the reference. This is your reference. Here your 200 volts, it is 0 degree, it is all along the reference. See here, I has got a magnitude of 641 and it is minus 15. Minus 15 means you have to take in the anti-clockwise direction. Therefore, my current is 6.41. It is lagging an angle of 15.47 degree. It is lagging. Now, what is asked is, what is the phi you are getting? Phi you are getting as 15.47. We have to write this as lag.